Okay, finish with this example. Here, this is the joint PMF given earlier as an example. Now, first of all, I'm going to show you how to compute the marginal PMFs on this joint PMF. What you do is, for a particular value of x1, if you want to obtain the marginal PMF of x1 at that particular value, you just need to add up all possible PMF values for that particular value. For instance, to obtain the marginal PMF of x1 at 0, you just look at where x1 is 0 on this line. So on this line, this entire line, you just squeeze them together. So you have just this probability and this probability. So for x2 equals 2, you have this probability. x2 equals 5, you get this probability. You just add them up. 0.16, 0.24, you get 0.4. Similarly, here, when x1 is 1, you are on this line. Okay, so for x2 equals 2, you get this probability. For x2 equals 5, you get this probability. Add them together, you get 0.3. Okay, and again, for x1 equals 4, right? You get, when x2 is 2, you get 0.12. For x2 equals 5, you get 0.18. Add them together, you get 0.3. This is the PMF. You see 0.4, 0.3, 0.3. Add them up, you get 1 as expected. And none of them are negative. How did we compute this? We just actually squeezed this to the x1 axis. So that is the reason we call these marginal. You go to the margin, okay? And then you just look from this perspective, let's say, and whatever probability you see is the probability of 0 here, these two. And when you look at this perspective to 0.1, you get this one and this one, you add them all up, you get this. And you look at from here to the value 4, you get this probability and this probability, combine them, you get this probability. Okay. And to obtain the marginal PMF of x2, you do the same thing from this perspective. Okay, so you all add them up to this axis here. So when you look from this perspective, for x2 equals 2, you get this probability, 0.16, you get this 0.12, you get this 0.12, you add them up, you get 0.4. And when you look at x2 equals 5 from this direction, you get 0.24, 0.18, and 0.18. Add them all up, so you combine them on this line, what you get is 0.6. So these are the marginals. Okay, now let me clear up. Okay, and when you look at the marginal PMFs, and when you look at individual points, you see that the product form actually holds. Well, you can actually compute the conditional PMFs, which I will not do. Well, here we have just two components, and we see that the product form holds. For any point you pick here, for instance, this one, x1 is 1, x2 is 2. So x1 is 1 here, x2 is 2 here. 0.3, 0.4, multiply them, you get 0.12. Okay, or this one here, for instance, take this x1 equals 4 and this x2 equals 2. You get here this point here and multiply them, 0.3, 0.4, you get 0.12, right? Or you get this point, x1 is 0, so you get 0.4, and x2 is 5, you get 0.6, multiply them, you get 0.24. Okay, so the product form holds, which shows me that x1 and x2 are indeed independent. And in fact, if you actually look at the joint PMF, you see this just look at this line. Okay, you see 0.16, 0.12, 0.12. If you normalize it, you get this distribution. Or if you get this line, well, this distribution is what? The distribution, well, before normalization, the conditional distribution of x1 given x2 is 5. Or this one, x1 given x2 is 2. Okay, so you get the same 0.24, 0.18, 0.18. If you normalize it, meaning that you add them up, 0.24, 0.18, 0.18, you get 0.6. Divide by 0.6, divide by 0.6, divide by 0.6, you get this distribution. Okay, or look at it the other way around. From this axis, you get 0.24, 0.16. So you get, when you normalize, you get this distribution. And this one, this line here, if you just look at this line, this is the conditional PMF of x2 given the value of x1 is 1. Well, you have to normalize it, but 0.18, 0.12, divide by 0.3, divide by 0.3, you get this distribution. Okay, so we see that x1 and x2 indeed in this example are independent.